Hello everyone, welcome back to the course on architectural design of ICs. So we are seeing different architecture, efficient architecture from different algorithm. Okay. So in considering or in corresponds to considering design aspects of VLSI design aspects of speed, power and area. Okay. So in the last class we have seen one function which I need to implement, that is y equals to ceiling of log 2 base x. Okay. So that I want to design, or that I want to implement using the circuit, or that circuit I need to design. So at that time how we can do, we have seen that we have done what we have just drawn the operation table, and from that operation table now our job will be, we have to find out each of the logical expression for each of this bit, okay, output bit, and then from that particular, after finding out the logical expression for each of these output bits, then we will just convert it to the, or we will draw the architecture of that particular circuit, okay, or we will get the hardware for that particular circuit. Okay. So we have drawn the, that means this operation table. Okay. So we have got how these inputs, how the outputs are basically affected by the combination of input, that we have seen in that operation table, that we have already drawn. So from that we have concluded that this is nothing but a priority encoder circuit. So now we will try to design one priority encoder circuit which will give me the function of y equals to CL of log 2 base x. Okay. So then again go back to the that means corresponding circuit. Okay. So if I just draw again, if I just, that means quickly draw that particular point. Okay. So what I need to do, that is y equals to log 2 x. Okay. So now what we have seen, sorry, y equals to log 2 base x, that I need to implement. So what we have seen, that for x of 0 to 1 there is a range, for 2 to 3, then 4 to 7, then 8 to 15, 16 to 31, and 32 to 63, 64 to 127, 128 to 255. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and for that, what will be the, that means this value, or this, sorry, this is x. If I just write it in another terms, if this is x7, x6, x5, x4, x3, x2, x1 and x0. So initially it will be something like this, and for that the output, which is nothing but implementing this particular function. So as I am considering 8 bit, so that is why I can, using this particular, sorry, y2, y1 and y0, using 3 bit I can implement. So and then if I just write it in the, as we have seen that the range is 2 to 3, that means if this bit position is 1 and whatever is the value of this x0, it does not matter, the value will be something like 0, 0, 1. Okay. So that we have already seen. Let me draw it again. So just quickly I am doing that. Okay. So then for 4, this is for 5, this is 6, and this is for 7. Okay. So this is my table. So now from this particular point, now what will be the logical expression for this y0? So how we basically actually what is the general method for finding out this y0? I have to draw or I have to put it to the Carnot map, and from that I can find out the logical expression. But considering 8 bit variables on that using this Carnot map, it is become too much complex. Okay. So, we have to find out another method, or we have to follow another method for calculating the logical expression for that. But here what we can do, we have seen, we can see that okay, for 1 this, then this is for 1, then this is sorry, this is for 2, then this is for, if I just consider, okay, let me consider another, for Q0 that will be for 1, okay, then this is 1 for which period 3, then this is 1 at which bit position, then 5, and this is 1 for 7. Okay. For this particular bit position, this Q0 value is 1. So, that means if I just write, that means at this particular point, for this, for this, and for this y0 bit is 1. So, now I have to find out the corresponding expression for this. Okay. So, how can I find out the corresponding expression for this? So, initially as I told you that this is priority encoder circuit. So, this, when this bit position is basically, this means what? If I just write it as the that means term as D1 plus D3 plus D5 plus D7, these are the, that means corresponding expression of this particular bit position. So, if I just write that as a function, the D1 plus D3 plus D5 plus D7, that is the Q0. Okay. So, if you just see, whenever this bit position is 1, no matter whatever the value of others, it does not depend on them, it depending only this x7 bit position, it basically gives you the value of 1 at Q, that means y0, this is y0. So, that means now for D7 what I can write? I can write that as a x7. Okay. So, I am trying to find out each of the expression for this D1, D3, D5 and D7. So, D7 is basically nothing but your x7, because this is all of these are do not care bit position. So, only if this bit is 1, so obviously this will be 1. Then for D5, D5 means this. So, here you see I am having the, that means the B, that means corresponding 1 at D5, that means for x5. What about these two particular bit position? So, at that time these two particular bit position, that is 0 and 0. But here you see I have already, as this is priority encoder, so I have already got 1 at this particular bit position. So, that means for these two, the expression for D5, it will depend only these two particular bit position, and it will be something like x6 bar x5. Okay. Then for 3, if I just go to, or if you just go to this particular bit position, so at that time you see this is already becoming, that means for this expression I have already considered this particular bit position, or I have already got this one here and I have already got this one here. So, for this particular combination, what will be the, that means case, or what will be the expression for that? It will depend on the corresponding bit of x6 bar, then x4 x4 bar and x3. Okay. So, that means, as I have already got 1 over here and this one for this 5. So, I do not need to consider this 2 bit at for considering this. Why? Because this is priority encoder. So, if this bit position is 1, already that will affect this. Okay. Then for 1, I have got 1 over here, I have got 1 over here, I have got 1 over here. Okay. So, then for this only I have to consider this 4 I have to consider. So, for D1 now I can write the expression as x6 bar, x2 bar and x1. Okay. So, this is the final expression of y0. By the same method, if I want to find this y2, so y2 means what? Y2 is basically for, this is for 2, y2 is basically for 2 and then 3 and then this is 6 and then 7. Okay. So, using the same method for 7 it is x7, for 6 means what? For 6 means what? I have already got this. So, here what we are getting? 6. So, 6 means this already I got. So, only this x6 plus 3 means what? For 3 what is the bit position? So, for 3 is this. So, these 2 bit position I have already got 1. So, this will be x5 bar, x4 bar, x3. Okay. Sorry, this for this 3 na. So, this I already got. So, this and this. So, for 3 it will be x5 bar, x4 bar, x3, and for 2 what I got? I have got 1 over here, 1 over here and 1 over here. So, rest of the things I need to consider, which is x5 bar, x4 bar and x5 bar, x4 bar, and I have got 1 over here and then this is x2. Okay. So, that means x7, x6 and 3 I got, only what I left? 5, 4 and 2. Okay. So, that is the expression for y2. So, then again what will be the expression for y3 then? So, for y3 the expression will be, this is 4, 5, 6 and 7. So, for 7 this is x7, for 6 this is already I got 1 over here. So, this is x6. So, for 5 this 2 is already I got 1 over here. So, for this is x5. For 4, 7, 6 and 5 both I got 1. So, all 3 I got 1. So, for 4 this is only x4. So, this is the expression for y3. So, now that means for y0 the expression is something like this, x7, then for 5 that is x6 bar x5, then for x3 is x6 bar, x4 bar, x3 plus for 1 it will be x6 bar, x4 bar, then x2 bar, x1. Okay. For y1 what was the case? For y1 it was 2, 3, 6, 7. So, that means for 7 it was this, for x 6 it was x 6, for 3 x 5 x 4 bar x 3 plus x 5 bar x 4 bar x 2, and for y 2 for y 2 it was x 7 plus x 6 plus x 5 plus x 4. Okay. So, now if I just write this expression as x 7 plus x 6 plus x 5 bar x 4 bar x 3 plus x 2. Okay. So, this also I can just minimize and I can just write, and then for that what I need? I need this OR gate and AND gate. So, in combination of that, if I just, that means if I just write or draw a particular only one, that means this is x 7 and x 6. Okay. So, then again I need one OR gate. Okay. And here if I just like draw this x 5 and x 4, then x 3 and x 2. So, this will become this, then x 5 bar, and I need one AND gate where this is x 5 bar x 4 bar. Okay. So, this will be then ANDed with this x 3 plus x 2. Okay. And then that will be added with this particular point. So, this is y 2, this is y 1, then for again y 0 I have to just minimize this, and by this method using these gates now I can implement that 8:3 bit priority encoder circuit, which will give me nothing but that y equals to log 2x. Okay. So, that means now you can implement this circuit, which will, from where you can get this log 2 base x. Now, next from this particular point, let us consider another circuit. Suppose I need one circuit which is 2 to the power of this log 2 base x. So, at that time how actually what will be the circuit for that? So, for that again the same thing, that means for x the range will be same. Okay. It will be 4 to 7, something like this, then 8 to 15, then 16 to 31, then 32 to 63, then 64 to 127, then 128 to 255. Okay. Then for this x, that can again write as x 7, x 6, x 5, x 4, x 3, x 2, x 1 and x 0. So, that again can be written as something like this. In the earlier case, what we have seen, the same thing. Okay. So, where will be the change? If I consider this, at that time where will be the change, that we just want to see, or that we have to see. Okay. So, if I just, sorry, this is 0, then 0, 1, then something like this. Okay. then this y equals to 2 this log 2 base x. That means, if I consider only this, at the time it will give you 3 bit, that is 0 0 0, 0 0 1, then 0 1 0. So, 2 to the power of, if I consider this as a, suppose I am considering this x as, let us consider this as a y. Okay. So, now sorry, if I consider that as a p. Now, y will be what? 2 to the power of p. So, 2 to the power of p, we have seen how, we have seen y equals to 2 to the power x, right. That means, nothing but a decoder circuit. Okay. So, that means, now in the decoder circuit for 3 bit, how many combination I will get? I will get 8. So, that means, now for this particular y, y7, sorry y6, y5, y4, y3, y4, y3, y2, y1 and y0. For this it will be 1 over here. For 2, sorry, for what I am getting? 0 0 0 for p or for log 2 base x. So, now 2 to the power 0 means I am getting 1 over here. So, 2 to the power 2 1 means I am getting 2, that means now it will be this, something like this 2, then I will get 4, then I will get 8. Then I will get what? I will get 16. Then I will get 32. Then 64. And then this is 128. Okay. So, 16, 32, 64, 128, sorry 256. 1, 2, 4. Sorry 1, 2, 4, 8, 16, 32, 64, 128. Okay. So, this is a table which I am getting. So, now what will be the expression for each of this y0 after considering this? If you just consider, or if you just want to map from this to this, then what it will be? So, y0 means here, that is, if that is 1, okay. So, at that time, if I consider this, so at that time it means what? If all of these combinations is, that means all of these combinations are considering that all zeros. So, at that time it will be 1. So, that means no matter the values of this, whatever is the values of this, all these bit positions, if it is considering for y0 to be 1. Okay. So, for y1, if I consider all of these particular bit positions, so then because this can vary. Okay, so I will discard this particular bit position. Only for these particular bits, this will indicate 1. Okay. Because this will vary. If I consider this, then I have to consider 0 and 1 for both the cases. So, considering that whatever is the value for this, if I consider the other, that means from this particular x0, excluding that x0, if I consider the other bits, combination of that particular point will give me the output of y1 over here. So, y0 means what? When all these bits are 0, then it is 1. So, that means now that is what? That will be just x7 bar, sorry, not bar of x7, x6, x5 plus x4 plus x3 plus x2 plus x1. So, that means OR of all these bits that you will get y0. Okay. So, for y1 what will be the expression? For y1, if all these bits, are if all of these bits are 0 and along with this is 1, then only I will get y1 over here. Okay. So, that means now I have to, or I can write this corresponding expression in the same fashion. Okay. So, that means now for this particular bit position, for this y7 x7 to x6, sorry, x7 to x2 and x1, I have to write this. So, what will be the, that means corresponding function? Okay, let us consider for this, for y7, if x7 is 1, so y7 will be 1. Okay. For y6, this is 1, x6 is 1, and for x7, if these two combinations are same, because in the previous case what was there, that means I am considering this bit position whenever I am getting, that means I am getting for multiple 1. Whenever I am getting y7 multiple 1, at that time I can exclude this particular point, but here I am not getting multiple of 1 over for this y7 or y6, only for one particular position this is considering this. Okay. So, that means now whenever this x6 is 1, so I am getting 1 over here. So, that means now I can write that as x6. Okay. So, now for y7, sorry, for y5, no matter the values of others are, okay. So, whenever I am getting this as, at that time I will get, if this is 1, so obviously I will get 1 over here. So, in this fashion, this same as this, same for this, same for this, and only for this particular bit position it will change, which is something like this. Okay. So, for y4, that is, sorry, for y4 that is x4, for y3 that is x3, for y2 that is x2, and for y1 that is x1, for y0 it will be this. Okay. So, this can be the, or if I just implement the logic, that means connecting this x5, sorry, x7 bit as y7, then x6 to y6, then x5 to y5, no, sorry, no, actually we have to consider this, because for y6, for 1 this can vary, right, as this position is do not care. So, at that time it will be different, it will be some say on the same. So, as I am getting 1 over here, so that means it will be x7 bar into x6, x7 bar into x6. Okay. So, and for this it will be x7 bar, x6 bar, x5. Okay. For y4 it will be x4 multiplied with x7 bar, x6 bar and x5 bar. For this it will be x7 bar, x6 bar, x5 bar and x4 bar. Okay. For x2 it will be x7 bar, x6 bar, x5 bar, x4 bar and x3 bar. Okay, if I just write it in a different, that means for y7 it will be y7, for y6 it will be it will just depend upon this 0 and 1. Okay. So, that means it will be sorry this is x7 bar into x6. For y5 this is x7 bar, x6 bar, x5 and for y4 that is x7 bar, x6 bar, x4 bar, sorry x5 bar, x4. For y3 that is x7 bar, x6 bar, x5 bar, x4 bar and x3. For y2 that is x7 bar, x6 bar, x5 bar, x4 bar and x3 bar, x2. For y1 that is x7 bar, x6 bar, x5 bar, x4 bar, x3 bar, x2 bar, x1. Okay. And for y0, if I consider, so at that time what it will be, that means x7 bar, x6 bar, x5 bar, x4 bar, x3 bar, x2 bar. Okay. So, when all this or if you sorry this one, if I just consider when all these bits are 0 0 0 0, so at that time only it will I will get 1 for this. So, whenever I where I will get, that means when all of these bits is zeros, okay. So, then I can get 1 for this particular point, okay. Or else I can just write in terms of or and then invert of that, the same logic. Now, that means this is the corresponding expression for this y equals to 2 log 2 x. Okay. So, now using just AND gate, that means now y7 sorry x7 that will be directly connected to x7. Then we have to, that means connect something this x1 bar, x2 bar, okay, x2 bar, then that will be connected with this. So, this now this basically this function now I can implement using this gate. Okay. So, for that x1 and x2 bar that I have, so then x3 and sorry x2 not this. So, if you just consider this x3 and x2 they are common. So, x3 and x3 bar, x2 bar is common, that I can sorry this is NAND gate, AND gate, this is not NAND gate, x1 bar, okay. Then what I need else x4 and x5. So, x4 bar, x5 bar, then what I need x6 and x7, x7, x7 bar. Okay. So, then this will be so this is y0, right. Okay. So, then for y1 what I need? I need x7, x6 bar, then x5, x4 bar and then x3, x2 bar. Okay. So, here what we are doing x7, x6 and from here we will get another which is this . So, along with this x3, x2, then along with this I need to AND it with x1, then again this will be ANDed with another gate which is x 1, and from that particular point we will get y 1 over here. Okay. For this y 2, what I need x 7, x 6, x 5, x 4. So, x 7, x 6, x 5 and x 4. Then what I need x 3 and x 2. So, x 3 and x 2 again I have to design, or I have to do this x 3 bar and x 2. So, then again I can do, or I can just implement this y 2. So, in this manner, or in this, for this particular, that means expression, now using this AND gate only I can implement it. Okay. So, in earlier case, in priority encoder circuit, okay, we are basically what we are doing, we are just finding out this expression for 3-bit position, but here for 2 to the power of log 2 base x, we are getting 8 number of expression over here. So, 8 expression we have to find out, and then for each of the logical expression we have to convert it to the corresponding gate level. Okay. So, thank you for today's class. This is the, that means end of architecture to, sorry, algorithm to architecture mapping. So, in the next class we will start with different things. Thank you.